If we take a sequence and replace each of the commas in that sequence with a plus sign, we now have a series. If we add up each term within that series, we can find the sum of that particular series. So if we have an arithmetic series, remember an arithmetic sequence is where we're taking the first term and we're adding a common difference on each time. Then the sum of that arithmetic series is just adding up all the terms. So term 1 plus term 2 plus term 3. And then remember, this is the formula for the general term. So we're adding up every term until we get to that last term. Together, that will give us the sum of that series. So let's take a series, and it is an arithmetic series because we're adding a common difference of 3 each time. And if I ask you to calculate the sum of that series, what number would you come up with? So from previous experience, a lot of students will go 2 plus 5 plus 8 plus 11, and that will give you the sum. But I want you to notice something else. I would add 2 plus 23, and when we do that, we get 25. And then I would add 5 plus 20, and when we do that, we also get 25. And then if we move in here, 8 plus 17 is going to give us 25. And 11 plus 14 will also give us 25. So a faster way, if you have an arithmetic series, is to figure out what's the sum of the first and the last term, because that will be the sum of every pair of numbers as we work our way into the middle here. And then you can figure out how many pairs you have. So we have 4 pairs of 25, and that will give us a sum of 100. What if we have an odd number of terms in our series? So in this particular case, we can again add the first and the last term to get 26. Second and second last, we get the same sum, and then that middle term is going to be half the sum there. So in this case, we have 2.5 pairs times the sum of 26 will give us 65, the sum of that series. So what we're doing when we're trying to calculate the sum of an arithmetic series is we're essentially adding up what's the value of that first term plus the last term, and then we're multiplying by the number of pairs. The number of pairs we have is the number of terms divided by 2, so this is the number of pairs times the sum of each pair. So if we know the value of that last term, we can use this formula to calculate the sum. If we don't know the value of that last term, remember back to arithmetic sequences, we can calculate the value of that general term by taking the first term and then adding however many common differences we have to it. So essentially, T sub n is found using this formula. So if we do not know the last term, then we're going to still take this same part of the formula, but instead of just putting that number in there, we're going to calculate the value of that first of all. So now if we go to simplify this, we can add those two term ones together, and we can simplify this down to this formula. So if we know the last term, we can just put the value in. If we don't know it, we're going to calculate that value first of all. Okay, so let's try this out here. I have a series, and the first thing I'm going to do is check to see, is it arithmetic? So I am adding the same difference on every time. So it is arithmetic. I do not know what the last term is. I'm trying to calculate the sum of the first 50 terms. So I'm going to use this formula where I'm going to have to calculate the value of that 50th term in there. So we're going to start substituting in. So I have 50 terms, so we're looking for the sum of those 50 terms. I know that my first term is 3, so we have 2 term 1s. If there's 50 terms that we're adding up, n minus 1, so 50 minus 1 means I have 49 common differences, and we already established that the common difference is 1.5. So then we can go ahead and simplify this. 50 divided by 2 is 25. 2 times 3 is 6. Multiply those together and then get that value. We're going to work out the bracket first, so add those up, multiply them together, and we now have the sum of the first 50 terms. And one more time, this time we're looking for the sum of the first 69 terms for this series. Check first of all, is it arithmetic? So each time we're adding -2, so it is going to be arithmetic. So we have 69 terms divided by 2. This is how many pairs we'll have. 2 times the first term plus, if there are 69 terms, we will have 68 common differences of -2. Go ahead and simplify, and we can quickly get the sum of those terms. If we're given the last term in the series, then we can use this formula. So we've got the first term, we've got the last term. Let's go ahead and substitute those in. But we don't know what n is. We don't know how many terms there are in here. Well, we do know that this is arithmetic. And we know from our previous lesson, arithmetic sequences, that we can calculate the number of terms in a sequence using this formula. So let's take the last term in that sequence, in this case it's a series, is equal to the first term plus n minus 1 common differences, and we've got the common difference up here. So now I can go ahead and solve for n, and when I do that, I now see that there are 12 terms in this series. So we can put the 12 in there in the place of n. 12 divided by 2 is 6. 6 times 56 is 336. That's the sum of the 12 terms in that series. This question is the same concept where we're given the first term and we're given the last term and we're looking for the sum of that series. I'm just going to show you some shortcuts because we are now dealing with fractions. So I can see that I have a denominator of 8 all the way along, but I'm going to first of all convert these mixed numbers into improper fractions just because they're easier to work with. And then I can see that I'm subtracting 4/8 every time. So it is going to be an arithmetic series. So we can go ahead and use this formula. I know the first term is 17/8. I know the last term is that negative 23/8. And again, we need to calculate the value of n. So we're going to scoot over here and we're going to say, okay, we know the last term, we know the first term, and we're looking for n minus 1 common differences. And I'm going to just leave it, this is negative 1/2, but because all of my denominators are 8, and I need a common denominator if I'm adding or subtracting, I'm just going to leave it for right now. So when we go to simplify, we're going to multiply this in to get rid of those brackets, and then really quickly I can go 17 plus 4 is 21, keep the denominator the same, and then when I go to subtract this out, I'm going to subtract 21 to get that negative 44, keep the denominator the same, and then this is the cool part, when we go to divide this out, remember when we divide fractions, we multiply by the reciprocal. So this is going to end up reciprocating, the 8 will be on top, and it's going to cancel with that 8. Maybe let's just write this on the side here so you can see, and then mentally, you can go negative 44 divided by negative 4, we know is 11. And again, remember, n has to be a whole positive number. So if it's not, there's a problem, go back and check your work. All right, so we're going to take that 11, substitute it in the place of n, and then we've got 11 halves times negative 6/8. And again, here's what I would do. I would say, okay, I've got negative 6 divided by 2. We can go negative 6 divided by 2 is negative 3 on top. So 11 times negative 3 is that negative 33. 8 is on the denominator. We can't reduce that any further, so that is our sum. In our last example, we're told that we have an arithmetic series. We're also given the sum of the first 2 terms and the sum of the first 4 terms. We have to determine what the first 6 terms of that series would be, as well as what the sum of 20 terms would be. So there's some information that we need to get here. So we need to know where are we starting from. So what is that first term, as well as what is the common difference going to be? So let's think about what we know. We do know the sum for each of those 2 series. We also know the number of terms. So we have 2 terms in this one, we have 4 terms in this one. We don't know the first term, so we're going to leave that as a variable. We also know the number of common differences, because if there's 2 terms, 2 minus 1 is 1 common difference. If there's 4 terms, 4 minus 1 is 3 common differences. We don't know that common difference. But if there's only 2 variables that we don't know, we can set up a system. So let's go ahead and put some values in here. So in this first series, we have a sum of 19, 2 terms, we don't know term 1, but n minus 1, we have 1 common difference. In my second series, we have 4 terms. The sum of that series is 50, so we put in a 4 for n, and then if n is 4, we have 3 common differences. So now let's go ahead and simplify this. 2 divided by 2 is 1, 4 divided by 2 is 2. So what we're going to do, instead of multiplying this in, we're actually going to divide this out. So we're going to go 19 divided by 1, which is 19. We're going to go 50 divided by 2, which is just 25, and we can simplify each of those down to get a system that we can now solve. Subtract to eliminate those term 1s. 19 minus 25 is negative 6. 1 minus 3d is negative 2d, which gives us a common difference of 3. We can then substitute that back into one of those equations. This one is the easier one to use, so I'm going to take that one. Substitute 3 in the place of d, and then we can go ahead and solve for term 1. And then you can always check this. So if we have 8 right here, and we have a common difference of 3, 8 plus 3 is 11, 8 plus 11 will add to 19. We can now go ahead and determine the first 6 terms of the series. So begin with term 1 of 8, and we're adding on a common difference of 3 each time. And then the sum of 20 terms, n is going to be 20. We have 2 term 1s plus 20 terms minus 1 means we have 19 common differences of 3, which gives us a sum of 730 for the first 20 terms in that series.